Welcome, students. In our last lesson, we introduced this idea of prime and composite numbers. So just briefly, let's take a look again at what these terms prime and composite mean. So a prime number, prime number is a number whose only factors are 1 and itself. For example, the number 5. The only way to make the number 5 is 1 times 5, or 5 times 1. But either way, it only has two factors, 1 and 5. Those are the only factors of 5. There's no other way to make 5. The other number that we learned about is a composite number. Composite number. And a composite number has more than two factors. For example, the number 6. What are some ways to make the number 6? We can multiply 2 times 3, or we can multiply 1 times 6. And right away, I'm just going to change the color here just to show how it's different. I see that I have 1, 2, 3 different factors. 2 and 3 and 1, and 6. That's 4 factors. So the number 6 has 4 factors. How about the number 7? The only way to make the number 7 is 1 times 7. So 7 is another prime number. It only has 2 factors, 1 and 7. Well, how about the number 10? 10 is a composite number because we can multiply 1 times 10, but we can also multiply 2 times 5. So we can see that 10 has 1, 2, 3, 4 factors and is therefore a composite number. So in today's work, we're going to try to find all of the prime numbers, because prime numbers are going to be useful to us. We're going to find them, and they're going to be useful to us because they're going to help us solve some problems later on. So it's actually kind of a handy thing to know how to use and to find. So this here is called the Sieve of Eratosthenes. What is a sieve? Well, if you've ever baked before, you might have used a sieve. A sieve it's kind of something that's like a colander, sort of, and you put, here's a little handle over here, and what you do is you actually pour flour into a sieve. So you might have a bag, and let's see, here's my little bag of flour, and you pour the flour in, and it fills up with flour, and a sieve just lets out small bits of material through the little tiny holes. And so this Sieve of Eratosthenes is a way of doing that, to find the prime numbers are the little numbers that are going to escape through this rule that we're going to use here, this kind of method we're going to use here. How about this Eratosthenes? That's a crazy word, isn't it? Eratosthenes. Here's that word up here, Eratosthenes. Now, Eratosthenes was actually, Eratosthenes was this old guy that lived about, he lived about 2,000 years ago in ancient Greece. And Eratosthenes, he had kind of a beard, if I remember looking at the statue, and he was kind of bald, so he had a little bit of hair in the back here. And Eratosthenes was a mathematician. And he actually did a lot of really cool work. He was one of the first people to ever measure the circumference of the Earth. So he was one of the first people he kind of had an idea. Oh, I've got an idea. And he was able to measure the circumference of the Earth just by measuring shadows. We'll get into that more later. But for now, we're going to talk about this guy Eratosthenes. If you're wondering how to spell his name, it's spelled like air. It's kind of spelled like, let's see here. spelled like error, let's see here, Eratosthenes. That's just how you spell it, Eratosthenes. Okay, so the Sieve of Eratosthenes is a way of catching all the prime numbers. And so we're going to go ahead and work on this. I'm going to get it started for you, and you're going to finish it. Now, you have this material in your Montessori materials packet, or you can find it here in Schoology. It's under the math folder in the materials. You'll see it on top here. Let's see here. Going to there. Week 5, math, and to the blue math there, under view attachments, 100 paper, Sieve of Eratosthenes, and you can share and open in Notability to work on that if you need to work on it digitally. So, for the Sieve of Eratosthenes, we're going to skip the number 1, so just cross out the number 1. Don't need that. Okay, because every number is a multiple of 1, if we're trying to find specific numbers, that's not going to be helpful. I'll show you why in a minute. So we're going to start with the first prime number, and we're going to underline it. Okay. Now we're going to cross out all the multiples of 2, because if it's a multiple of 2, we know it's not prime, because it has a factor of 2. So we're just going to cross out all the multiples of 2. So cross out all the multiples of 2. We're basically crossing out every other number here, right? All right, so I'm crossing out every single multiple of 2, and it doesn't take that long. I can go up to 50. I'll go up to 100. Now you see how I'm just skipping rows here. All right. Now I've crossed out every multiple of 2. Those are all composite numbers because they have factors that are 1 in themselves and also 2. So they can't be a prime number. They must be composite. All right, next up, I'm going to go to my next prime number, which is 3. It's the next number that isn't crossed out. And I'm going to cross out all the multiples of 3. So let's see, 3, 6, 9, 12 is already crossed out, 15, 18 is already crossed out, 21, 24, 27, 30 is already crossed out. Let's see here. 30, 33, 36, 39, let's see here, 42, 45, and so on. So I'm crossing out all the multiples of 3 the whole way down. You're just counting by 3s, right? It's just 1, 2, 3, cross it out. 1, 2, 3, cross it out. Simple as that, just counting by 3s. It's good practice. All right, next up for my sieve. Now you do that the whole way down. I'm not going to do that for, you can do that on your own. I don't need to show it in this example. This would take forever. We're going to find the next multiple, the next prime number, which is the next number which is not crossed out, the number 5. All right, now we're crossing out all the multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60 is already crossed out, 65, 70, 75, 80, and so on and so forth, the whole way down. So what we're doing here is we're revealing the prime numbers. So they're going to start showing up here as numbers which are not crossed out. So you see there's there's 2 there, and 3, and 5 is not crossed out. Next up would be the number 7. I'm going to underline 7. What are the multiples of 7? Well, there's 7. 14 is already crossed out. 21. 28 is already crossed out. Let's see here. We got 35. 42 is already crossed out. 49 would get crossed out because 49 is a multiple of 7. And so on and so forth the whole way down. All right, so that means that 7 would also be prime. Next up, our next number that is not crossed out would be 11. So the multiples of 11, that would be 11, 22 is already crossed out, 33 is already crossed out, 44, 55, 66, 77 needs to get crossed out. So you see, in this way, we can find all the prime numbers by just following this method. So what is the next prime number? That would be 13. So all the multiples of 13. Now you may find that they're already crossed out, but you're going to go ahead and do this, and this is your Sieve of Eratosthenes. So you're starting at the beginning. Now, it may help to watch this video again and just kind of follow along with the work that I'm doing here. And you're going to find the prime numbers. What are the numbers that are not, that do not have more than 2 factors? Sieve of Eratosthenes. When you're done with it, go ahead and just upload a picture of it or a screenshot of your work, and let me know if you have any questions.